Let's look at number 13 and number 14. So what am I going to do here? I'm going to take these two functions, add them together, and then replace the x with 5. So if I add these together, I have x minus 3 plus x squared plus 9. And if I combine like terms, I end up with x squared plus x, and negative 3 and positive 9 would be 6. Now I'm going to substitute in 5. So I have 5 squared plus 5 plus 6. 5 squared is 25. 25 plus 5 is 30. And 30 plus 6 is 36. Let's look next. Okay, let's look at part B. Let's look at part B. So part B, I'm going to do the same concept, but now I'm going to subtract. Now, where do I see a lot of students make mistakes here? When they subtract, they forget to write it out. And then they forget, by not writing out, that when they distribute, it has to be distributed to both terms, or all terms that are in the parentheses behind the subtraction sign. Okay, I'm going to write this in standard form. That means I'm going to order it. So I have the x squared, a positive x, a negative 3, and negative 9 is negative 12. Now we'll replace every x with a 3n. Notice that negative sign? It stays out front. It acts like a negative 1. This says write the base twice. So 3n times 3n. 3 times 3 is 9. N times n is n squared. And there we go. There's our expression. When I look at part C, I am multiplying these. So I'm going to take f times g. How am I going to do that? I'm going to FOIL front, outside, inside, last. And then I'll write it in order. And now I would go back and replace every x with an x. Well, that's not change anything. So this is what I have for an expression. Right. Make sure that was a 27, not looking like a 29. Okay, the next one we're going to take g and divide it by f. Okay, so g and divide it by f. There's nothing I can simplify. Remember, x squared plus 9 does not factor into x plus 9, or x plus 3, and x minus 3. That only occurs when this was a subtraction. So there's nothing more I can do. So this is what I'm going to write down for part D. Part E says, what is the domain of this? The domain of this, well, remember, the denominator can never equal 0. So I know x cannot equal 3. So it would be negative infinity all the way to 3, and 3 to positive infinity. Or you could write a number line like this, keeping 3 open and illustrating that everything else would be part of the domain. Done. I plug g of x into fx, always going backwards. So wherever I see an x in function f, I plug in what g of x is, and then I combine like terms. Let's do now the next one. Now I'm going to plug f into g. So let's write down what g is. Wherever I see the variable x, I leave a big spot. Then I have 1 over x minus 3. 1 times 3 is 3, so I have 3 over x minus 3. Subtract 1. We could go further, but I'd be comfortable with this. These 3's, by the way, cannot be reduced. You can't do that within math. If you wanted to make this real pretty, we could go and take this minus 1. We could make it into x minus 3, or we could do the butterfly method, but I am comfortable with you leaving it in this form. Now, what is the domain of this? So the domain of this would be this very first one. So let's look over here. What's the domain of this? We know the denominator can never equal 0, so 3x minus 4 cannot equal 0. So x cannot equal 4/3. So I'm comfortable with you doing 4/3 with a circle, and everything else is going to be shaded.